Dear students, Assalamu alaikum. Today our topic is about versatile nature of carbon. As we know that living things like plants and animals are composed of carbon, or we can state that all plants and animals are composed of carbon and its derivatives. That is why all those compounds which we obtain from these plants and animals are known as organic compounds. And the branch of chemistry which deals with the study of such compounds is known as organic chemistry. It is stated that more than 5 million compounds of carbon, or we can state that more than 5 million organic compounds are known till date. Such huge chunk of organic compounds are possible due to certain properties of carbon, and such nature of carbon is known as versatile nature of carbon. Before the discovery of organic chemistry, or before the discovery of organic compounds, it was believed that these organic compounds cannot be synthesized in the laboratory. And it was stated that there occurs a mysterious force and unknown force within the constants of these organic compounds. And this concept or this theory was known as vital force theory. The concept was given by a famous chemist known as Berzelius, and that is why it was also called as Berzelius hypothesis. After some time, there was a chemist in 1828. The name of the chemist was Frederick Wohler. He was doing an experiment in the laboratory where he was trying to mix ammonium chloride with potassium cyanide, and these two compounds result in the formation of ammonium cyanide. On heating this ammonium cyanide, it gets rearranged, or there occurs rearrangement reaction, and it gets converted into urea. After the discovery of this urea in the laboratory, this vital force theory or Berzelius hypothesis, it gets a huge setback. it gets a huge setback. And after this, it was stated that organic compounds can be synthesized in a laboratory, and there occurs a special force between the constituents of these organic compounds, and that is why from that point of view it was known, it was stated that this these organic compounds can be synthesized in the laboratory, and from that day this Frederick Wöhler is considered as the father of organic chemistry. And in this time, and we know that more than 5 million compounds of 5 million compounds of organic compounds are known. But what is the reason behind this versatile nature of carbon? We will try to disclose such properties here. The first property about which we will discuss is the self combination, is the self linking of these carbon atoms, and this self linkage of these carbon atoms is known as property of catenation. First property which shows us about the versatile nature of this carbon is catenation. Catenation, as I already told you people, that it is the self linkage of carbon atoms. Self linkage. Self linkage. Self linkage of carbon atoms to result in the formation of long chains. Long chains. Long chains. This dash sign indicates the valency, that carbon is tetravalent. And these carbon atoms, they self-link with each other. Carbon atom link with another carbon, another carbon, another carbon in a linear way, and results in the formation of chains. They can also link in a branched way to result in the formation of branches. Branches. They self-link with each other to result in the formation of closed structures. They self-link with each other to result in the formation of closed structures. Closed structures. These are called as rings. This self-linkage property of carbon atoms with another carbon atom is known as catenation. Because of this property of catenation, this carbon can result in the formation of a large number of compounds that in which that states us there. That shows us that carbon shows versatile nature because of this property of catenation. Next property is there that is tetravalent nature. We know that carbon has atomic number of 6, and when we will distribute these electrons in shells, 4 electrons are filled in shell L, which remains the valence or outermost shell of this carbon tetravalency. Carbon atom has atomic number of 6. When we distribute these electrons, K occupies 2 electrons, while L occupies 4 electrons. And these 4 electrons are present in the valence shell of carbon, and that is why we can state that carbon is tetravalent in nature. Because of this tetravalency, this carbon can combine with other 4 carbon atoms or other 4 monovalent or divalent carbon atoms. Second property, and then comes the size. The size of carbon is very small. The size of carbon is very small. And because of this small size, the size of carbon is very small, and because of this small size, carbon can form multiple bonds. Multiple bonds means it can form double covalent bond, it can form triple covalent bond with atoms like carbon with other carbon atom, with other similar carbon atom, with oxygen, or it can form multiple bond with another atom, that is nitrogen. Because of this small size, carbon atom can form multiple bonds with another carbon atom, with oxygen and with nitrogen. Carbon, because of this tetravalent nature, can form covalent bond, and due to this covalent bonding, carbon can result in the formation of a large number of compounds. In covalent bond, mutual sharing of electrons occurs. As carbon has 4 electrons in its outermost shell, as I already told you that it can neither lose these electrons, neither it can gain these electrons. But it has a choice that it shares its 4 electrons with other 4 atoms. There can be carbon atoms, there can be hydrogen atoms, or there can be any other atom to result in the formation of covalent bond. This mutual sharing of electrons of carbon with other atom can result in the formation of a single covalent bond, it can result in the formation of double covalent bond, it can result in the formation of triple covalent bond, or it can result in the formation of any multiple bond. Because of this formation of this covalent bond, this carbon shows versatile nature. Another factor, due to the property of electronegativity. Almost all the non-metals are electronegative. Carbon also shows the property of electronegativity, and the carbon has electronegativity of 2.5 on Pauling scale. According to this electronegativity, it is a property due to which any atom can gain shared pure electron from any other atom. This Carbon has the electronegativity of 2.5, and this electronegativity of this carbon, it compares with other atoms. It compares with phosphorus having electronegativity of 2.1. It compares with oxygen having 3.5. It compares with nitrogen having electronegativity of 3, and it compares with chlorine somehow having electronegativity of 3.3. Due to very less difference of electronegativity between carbon and other surrounding atoms of this carbon can form strong bonds. It can form strong bonds with these atoms. In case of carbon monoxide, in case of carbon tetraoxide, in case of cyanide, and due to this formation of strong bonds with these surrounding atoms, or due to comparison in case of electronegative property between between carbon and these surrounding atoms, carbon can form strong bonds in different compounds like carbon monoxide, cyanide, or carbon tetrachloride. That is why this carbon shows the versatile nature, and more than 5 million organic compounds are known till date. And this was all about versatile nature of carbon. Thank you.